Welcome to the Product Design and Development. This video is part of a series of videos that collectively will cover Product Design and Development course. So please make sure to check out the rest of the videos in this series. In this video, I will cover definition of a product and product development, what factors measure the success of a product development process, who is all involved, and what are some of the challenges ahead of the team. To start off, product as a generic description is anything that's sold by an enterprise or a firm to a customer. This could mean a product, or it could mean a service, or it could mean an experience. A product, we'll learn throughout this course that a proper definition of a product from mechanical design standpoint is a configuration of connected components that you have designed based on the constraint put out by the engineering team and by the customer. The 4 C's: configuration, connected components, and constraints. For example, a car, an impact driver, a tool, again, a physical product that you sell to a customer. It could mean a service, some activities or benefits that you offer to a customer, such as a plumber, a personal trainer. It could mean also a service, which is a representation of what buying a product will do for you or will do for the customer, such as Disney World. Product development is a collective sets of activities that will start with a perception of a market opportunity, a problem that you're trying to solve and address, and the process will end with production and sale of a product, which could mean any of these top ones. In this course specifically, when we say product, we mean the first definition of product, or the first meaning that we use here, and that's a physical, engineered, discrete, and physical product that is sold to a customer. Speaking of how do you measure the success of a product development, there are 5 features or 5 specific dimensions that kind of define. All of them ultimately relate to the profit, which is the bottom line of any business and any company. Again, nonprofits are exception, but any business, any engineering firm, any company, the bottom line is to make money and earn a profit. So these 5 features or these dimensions are used to measure success of a product development. They're divided into 2. One focuses on the manufacturing of the product, and another one focuses on the development process of the product. When you're looking at the manufacturing, cost and quality of the product are the 2 main factors. Product quality, in simple words, how good is your product that is a result of your development efforts. How do you measure quality? There are multiple features or factors that you can look into that speak to the quality of the product. Is how satisfied your customer is, or how much your product satisfy your customer requirements. Is your product is it robust and reliable? That's another aspect that speaks to the product quality. How much of the market share you can grab by this product? And finally, again, relating to that profit, how much is the customer willing to pay for this product? So the price that the customer is willing to pay for this product. is willing to pay for the product. when we look at the product cost, we're talking about a certain volume of the product. Whatever your product is and however many you are making per month, per year, that we're talking about the cost to make that product, which there are several factors. I mean, you got to consider raw material, the capital equipment that is needed, equipment that might be needed, tooling that you might need for making the product. Again, at the end of the day, that will determine how much profit you are going to make, because the more you put into the manufacturing of the product, that eats up into your profit margin. When we're looking at the other side of this balance, development and development cost, development time, and development capabilities. Talking about, start from the top. Capability is, did your firm, your product development team, your group, your division, however your companies are structured, did they grow as a result of this development process? Did they learn from this development process? And are they able to use this to better develop future products and use it to the benefit of the company? So capabilities talk about how much did you learn throughout this process? How much did you learn throughout this process? Time is another factor that can speak to your success of your product development. How quickly the product was developed. So how quickly, that's another factor. But also how responsive your team was, how responsive the team was to the competition and to technological advancement. Some products might take 2 or 3 or a year, 18 months to develop. During that time, the technology that you're developing is going to be evolved. What is available to you is going to be evolved. And what your competition is doing is going to be evolved. So this is how quickly you can respond to those changes and to the dynamic that is happening around you. So technological changes or advancements. Another big part of it, this is cost, but this is not cost of to make the product. This cost on this side is the cost of your development process, which is a big majority of it, and it's a big part of that initial investment that you need is a significant portion of initial investment. In initial investment for that product development. Here's an example that only focuses on 2 things. Good design, only focuses on design and manufacturing. I know these 2 were not directly in previous slide, those keywords, but it relates to a lot of those aspects, both the developments. Good design goes back to your development, but manufacturing goes on the other side of the balance for manufacturing. Good design, something positive, good design, and then we have poor design, negative, poor design, negative. We have manufacturing, efficient manufacturing, positive, inefficient, negative, efficient, positive, inefficient, negative. So positive, 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 negative, and vice versa. And you can see that affects your final cost that the product will get out of the company. Obviously efficient manufacturing in both cases has kind of lower price compared to the other side, but a good design and efficient manufacturing not only results in a cheaper production and product cost, but also it will result in a higher customer satisfaction. It speaks to that being robust, satisfying customer. And even if you increase your product price at this point, the customer is willing to pay for that because it's a higher quality product with more customer requirement satisfaction. So this is kind of a good example of putting some numbers into this. One question is like, who designs and develops products? Often when I ask this from engineering students, immediately they say engineers, which is correct, but is not a complete answer. There are a lot of different disciplines and functions within a company or a team are involved in developing a product. So the product development is an interdisciplinary activity which requires contribution from all functions of the firm. Starting with marketing. Marketing is the connection between the company and the customer. They kind of sets the target for the final price of the product, but also they help oversee the product sales, promotion, launch, and all of that in the company. Then we'll get to the design aspect of it, which could be the mechanical, electrical, software, material design and all of that, but it could be an industrial design, aesthetic part of the product, the ergonomics of it, the user interface of it, and all of that. So designers and the design, the literal design part of it is part of the product design and development process. And then manufacturing is the big part of the product development function in the interdisciplinary team. Again, that goes into, in manufacturing, starts in the design and kind of ends with manufacturing. So we're going to have videos later on design for manufacturing that speaks with this. The manufacturing starts early on the stage of the design with the design for manufacturing. But design, operation, and coordination of the production system. And when you combine it with purchase, distribution, installation, all of that, collectively we refer to them as supply chain. So a lot of functions, a lot of disciplines are involved in product development. It's not just engineers. Again, we're speaking only in the context of this class, but it's not just engineers. You've got to think that there are other aspects involved with it. Speaking of design, this is another question that I often ask a student. What is the difference between art and design, or creating an art and creating design? And there's a lot of differences and a lot that you can speak of, but I thought of 5 keywords that put here, and we talk about it. The biggest one being an intention. Design, usually when you create or design something, when we talk about engineering, in engineering terms, you have a set of goals and specifications that you're designing based off of. And either starting by customer requirement or by engineering specifications, you have sets goals and design targets to meet, versus art is created to just provoke your thoughts and emotion, and often after it's created, then it's find its purpose, and it could mean a lot of different things for a lot of different people. Another thing is design is not open for interpretation, versus art is. If your design is open to interpretation, that means that's a bad design. If you show someone a product and it's vague what it does, or a customer can't figure out how to use it, or what is it designed for, or what problem it exactly solves, that's a bad design. On the other hand, art is open-ended. It's open to interpretation and doesn't have a incorrect versus correct interpretation or description. Design has many rules. Some of it we're learning in this course, and the rules that you go, and a lot of engineering standards and a lot of standards that you got to follow, versus and if you follow those rules and processes and procedures, then your design is going to be consistent. Art is not sets of rules and sets of standards. I understand that they are, when we speak of a lot of creation of art, when we talk about a lot of illustrations, a lot of photography, a lot of creative art, there are certain rules. If you follow, your art is going to look like one way versus another. But we're talking about a set of standards that every artist has to follow. There's no such thing for art, versus in engineering, there is sets of failure criteria that any designer will follow when they're designing a certain part. Another thing is, in art, often the look is important and how it looks like. Again, depends on the art, but it's important how it looks like. Design, yes, it matters, but that's not the first priority of a product to look beautiful. A product that looks beautiful but cannot fulfill the function that was designed for is totally useless. So in design, again, we put more emphasis towards meeting the specifications and fulfilling the functions rather than how it looks like. And then finally, one of the most important ones kind of goes back to the rules. And that's what the focus of this class is design follows a specific process. And that's what this course is about. And in this course, we will follow a specific process, which is the mechanical design process to create a product. Versus art doesn't necessarily have a specific process for everybody that everybody has to follow. So I always thought this is a good comparison to kind of think about design, engineering design, I should say, versus creating an art. And then lastly, what I want to talk about is some of the challenges based on what we talked about. What are some of the challenges that the team face when they're working on the design and development? Something that we speak a lot in this course, and we'll learn some techniques how to deal with those, are the trade-offs. Trade-offs is when you want to maximize one of your spec, but that spec is affecting other aspect of the product development. And you got to choose or do a compromise. An example that's listed here is you can probably make an airplane lighter, but it's going to cost more. So you got to pick a sweet spot in between that kind of meet both of them. So trade-off is, when two engineering spec kind of go head to head, and you can't increase, maximize, or minimize both of them. Another one, the dynamics, we talked about a little bit. Customer needs, customer interests, the technology that's advancing and evolving, your competition is continuously evolving. So your team needs to kind of monitor all of that and be able to be quickly responsive to those changes. Some of the details, that the team needs to focus on, a lot of decisions that you will make. This could have been detail versus decisions. A lot of decisions that you will make, especially early on your product development, is going to affect the final product, the cost of it, the economics of it, and it has a lot of implications. And paying attention to these details and the decisions you're making along the way has a huge impact on the overall product development process. A lot of these decisions that we talked about, you can make the best decision if you have all the time in the world, but most of the time you don't. You got to make a quick decision, often based on a lot of unknown. So you got to work with what you have. You got to make the best decision with what is available to you at the time, and sometimes got to make that decision and move on. So there's always a time pressure with product development. And then finally, the economics of it. You got to also think about the marketing, the manufacturing of it, how much initial investment that you need for the product, and whoever is investing in this, whether it's your own money or shareholders or angel investors, whether it's Shark Tank, whoever is investing, what is the return on the investment? How are they going to get it? How long does it take it? Is it going to be successful or not? So these are some of the challenges ahead of the production team, product development team, for a product development process. Thank you.